We're going to go through a variety of different types of questions. And it's more about like exposure to them, being able to recognize in the future, that sort of thing. Okay? All right, so let's start with this one. So if you look at this polynomial, firstly, is there a common factor here? Yeah, x cubed, yes, absolutely. However, if we look at all of the fractional coefficients, then we can actually think about writing these as using a common denominator. What would the common denominator be between 3, 4, and 2? 12. Yeah, it's 12, okay? So if you think about 2/3, what would that be over 12? 8 over 12?
Oh, sorry.
Yeah, that's correct. And then 3/4? 9 over 12. And then 1/2? 6. Yeah, 6 over 12. Okay? So I'm going to rewrite this as 8x to the 7 over 12 minus 3x to the 5 over 12 plus 6x cubed over 12. Sorry, that should be a 9. Why is it not beside? Okay, good question. So if you see something like that, it's the same as x over 2. Because essentially what's going on between is that you're essentially sort of multiplying two fractions. You're multiplying 1/2 times x over 1, right? So 1 times x is 1, 2 times 1 is 2. Okay? Yeah, that's a good question, though, because some people, that's a really common source of confusion. Okay? So what we can do now is not only can we factor out the x cubed, but we could actually factor out 1 over the denominator as well. I'm going to factor out 1/12. Okay? And if I factor out 1/12 x cubed.
Wait, sorry, why are you doing 1/12 again?
Well, you'll see. Let's see what's left. Yes?
Can you just write that as x cubed over 12?
Yes, you can write it as x cubed over 12. Absolutely. Okay? Here, I've taken out the 12, and I've taken out 3 of those. So what's going to be left is 8x to the 4. Okay? Think about this times this. So 1x cubed times 8x to the 4 is 8x to the 7, and then over 12.
Oh.
Yes?
This ends up being the a squared plus b plus a constant.
Yes. Yeah, so let's see what's left. Here, we can take 3 x's out of there. We're left with 2 x's. We take the 12 out. We have negative 9x squared. Okay? And here we take the x cubed over 12 out. We just have plus 6. So what remains is actually a trinomial of the form ax squared plus bx plus c. And that may be factorable. Okay? In this particular case, our a value is 8, our c value is 6. We're looking for two numbers that multiply to 48 and then add to negative 9. I don't think we can do that. I don't think there are two numbers that exist where we can do that. So in this case, we're done. But you may end up with something, with a trinomial that can be factored further once you take out 1 over the LCD. Because what you end up with, essentially, is coefficients that are now whole numbers. Yes?
Isn't there a greatest common factor among the bracketed numbers?
No, because like 8 and 9 don't have any common factors.
Oh, yeah.
Right? Yeah, so this won't work, because if you think of what multiplies to 48, it's like 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8, right? So even if those are both negative, they're not going to add to negative 9. So here, this is not possible, which means that that's done. Okay, but it's possible that you could see another one where yes, you can factor further once you take out that denominator as well. Okay. Now, by the way, another way that you can see this, if you're having trouble going from here to here, I'm just going to erase this. So another way that you can see this is this way. Okay, so this is all written with a common denominator, yes? So you could also just write this with one denominator and have it be 8x to the 7 minus 9x to the 5 plus 6x cubed, right? Then in the numerator, you can factor out the x cubed, and you'll get x cubed times 8x to the 4 minus 9x squared plus 6 over 12. And so you can kind of see that this part is the same as that part. Okay, so that's another way of looking at it. Yes?
So you're factoring out the 12. Why don't you take anything from the numerator?
Why don't I take anything? Because in the numerator, I don't have any common factors. Right? Like if you think of 8, 9, and 6, there's no common factors there. And in fact, if you pick the least common denominator, you shouldn't have a common factor. You would only have a common factor if you pick a common denominator that's not the least common denominator. Or if potentially there may have been a common factor initially, right? And really the purpose for looking at it this way is, again, to see what's left and can that be factored further. Yes?
Do you have any more questions like these with the fractions that are on this sheet? Because I'm looking through and I can't find one.
There's some, I'm going to get you to do a whole bunch of practice once we go through all these examples together, and there is some in there. Yeah. Okay. Next. All right, so I've got 6x squared times 2a plus b minus 9x times 2a plus b minus 3 times 2a plus b. Okay? Yes?
If you do that thing where you take, I forgot what it's called, the front number and put them in a bracket by itself.
Well, what do you notice about each of these terms? There's like 3 terms in this polynomial. Yeah?
Does that end up doing the same thing as we just did, where it's like a squared plus b squared plus a constant? Because the variable x does that as that?
We will see in a minute. Yes?
All of the terms in the brackets are the same?
Yeah, so this binomial is the same, and each term is being multiplied by it. So you can take it out. That is a common factor amongst all 3 terms. Okay? So I can take that whole 2a plus b out, and what's going to remain is,
Squared minus 9x minus 3.
yeah. Okay, now let's work with this. What can we do here? Yeah.
Take out 3.
Yes. So we could take out a 3. And it doesn't really matter where you put the 3 because, remember, we're multiplying all these factors together. And in multiplication, order doesn't matter. But typically, if we're taking out a constant or a monomial, we put that term first. So I'm going to write the 3 all the way up here. And then think here, so 3 times 2x squared, and then 3 times 3 minus 3x, and then a 1.
Oh, this one.
Yes?
This one, then yours going from there because it does have the like C constant.
Yep, okay. So what are we going to be looking for?
Sorry, this is a question.
Oh, yeah.
Is there an extra step? Like, could you just factor out the 3 and the 2a plus b at the same time?
Yes, you can. Yeah, so the question was, can you factor them both out at the same time? And if you can recognize that, then yes, okay? But better if you can't to take it one step at a time so you don't make a mistake. Okay, so if we're looking at this, this is a trinomial of the form ax squared plus bx plus c. So we have to check to see if this is factorable. I don't think so either, because
It's not. I don't think.
yeah, we need two numbers that multiply to negative 2 and add to negative 3. And that's not going to be possible because the only numbers that multiply to negative 2 are 1 times negative 2 or negative 1 times 2. Okay? So this is not possible. But in another question it may be, right? Okay, so far so good? All right, let's look at another one. So here we've got x plus y squared minus 5 times x plus y plus 6. Okay, yes.
For the other question.
Oh, yeah,
up
yeah.
there, what if you took out the negative sign and put it in the,
Like if you took out a negative 3 here,
yeah, would that be possible?
you can do it, right?
But
Then
would
all
it
of the
make-
signs in here would change. But when you take out a negative sign, the purpose really, if you're working with a trinomial, is to make that a coefficient positive. So if it's already positive as a 6, I personally wouldn't take out a negative because then this becomes negative 3. This is now negative 2x squared, right? And I find it harder to factor trinomials when that a value is negative. But yes, you could. Mathematically, it would be equivalent. Yeah. Okay. All right, let's look at this guy. What do you notice? Yeah.
If you were to expand it, first part would be x plus y multiplied by x plus y.
Okay, yeah, so we could think about expanding this. Okay, certainly. And yes, we would have to go x plus y times x plus y. And then we'd have to distribute that negative 5 into the next bracket. Our goal, though, is to factor. So, yeah.
Can we take that x plus y out, or do we?
Okay, so we can't take it out because we don't have an x plus y in this term. But let's say that we let a equal x plus y. Then x plus y squared minus 5 times x plus y plus 6. If I replace x plus y with a's, what would this become? A squared, yes. And then minus 5a, and then plus 6. That is a trinomial of the form ax squared plus bx plus c. And this one, I believe, is factorable. Because in this case, we're looking for two numbers. This is a 1 that multiply to 6 and add to negative 5.
Negative 6 and 1.
Yeah.
Okay, but that doesn't multiply to 6. It does add to negative 5, yes. Negative 6 and 1, but it's not going to multiply to positive 6. So what else? Yeah. Negative 3, negative 2. Yeah. And because this is a 1, I can kind of cheat a little bit and just say a minus 3, a minus 2. Okay? Now that wasn't actually what I wanted to factor. So at the end of the day, I have to now sub back in the x plus y for a. So the original expression factored is going to be x plus y minus 3 times x plus y plus 3. Nope. Minus 2. What was I thinking of that? Sometimes I do things with, I don't know. I don't know what happens with my brain sometimes. Okay, minus 2. Oh, no, I don't want to do that. Okay. Come on. There we go. Okay. Okay, what is happening here? I don't want a text box. I want this and that. Ah, there we go. minus 2. This is like one of those cartoons.
It might be that the text box still exists there, so you're going to have to delete it.
I thought I deleted it already. Okay, hold on. Okay. It won't let me delete. I'll move it over. Oh my gosh. Okay, hold on. Here's what we're going to do. I'm just going to redo this right over here. So it's, yes?
What I would suggest, you see how it says text at the top?
Uh-huh.
Picking, one of the colors in the panels area.
I did that. So you go here and then here, right?
Now try drawing in the text box. That's my only, no.
Okay, but maybe now. See? Okay, here's what we're going to do. I'm going to
Selected a text box.
save it and close it and quit Notebook and then open it again. Now I have to find it wherever it went. Uh-oh. It's hiding. I'll just go open recent. Okay. Okay, come on. Open. This program is so slow. Okay. Come on. There we go. Okay. 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 I don't know what to say.
Instead of a pen. Do you want to try going to tools at the top? Oh dear.
Oh wait, I'm not on. So something's going on here, I can tell you that. It's been acting up. Okay, I want the pen. Okay, there we go.
Yay!
Woo! Okay, so then at the end of the day, this is okay, but we don't really need the brackets around x plus y. So you could just write this as x plus y minus 3 times x plus y minus.
Don't you have to substitute in the plus 6 and the minus 5 down too?
So the plus 6 and minus,
Sorry, that's already there.
yeah, that was in the expanded form. Yeah,
Yeah, my bad, I'm slow.
all good. Okay, so far so good?
Yeah.
Okay, so actually, oh, you know what? There's a typo on number 4. Can you guys please put a squared there?
Oh yeah, we did this yesterday.
Yeah, so we did something really similar to this yesterday. As long as this is double that, we can factor it. Okay, so here we're looking for two numbers that would multiply to negative 27 and add to negative 6. Okay, so what works? Yep.
I believe, sorry, oh, I had it.
Okay. Yep.
-9 and then positive 3.
Yep, negative 9 and 3. And because this is a 1, I can just factor directly. So I'm going to go x squared minus 9 times x squared plus 3. Okay.
Could you show the longer way to do it?
Yes, I can. Okay, so if you could either use a box or decomposition. And we can, like, I'll do a couple of examples so that we can see both. If you were using, like, a box, then your x to the 4 goes there. And your negative 27 goes there. And then those two numbers, negative 9 and 3, break up the middle term. So minus 9x squared and then plus 3x squared.
Okay.
Okay?
And you don't have y and x forward.
No,
y.
no.
You can just do it.
Yeah.
Like,
Yeah,
oh, you can just do it
absolutely.
like that, then that's fine.
Yep. And then here we want to factor the GCF is here is x squared. And you're left with x squared minus 9. And here the GCF is also x squared
Okay.
plus 3.
Cool.
Okay? Okay, so is that it?
Yep. No. Wait. No.
Nope.
You can still. You have x squared minus 9 is squares.
Yeah, there's a difference of squares, right? So this we can break down even further. This is just x squared plus 3, but this guy is x plus 3, x minus 3 times x
And
minus
when you're doing a difference of squares, you always get rid of that second degree, right?
3. Yes,
Okay.
correct. Yeah.
I don't really understand the difference of squares thing.
Okay, so should we review difference of squares? Think of the reason why difference of squares works is that you can turn, if you look at x squared minus 9, think about it this way, x squared plus 0x minus 9, right? And then it's kind of artificially a trinomial where you're looking for two numbers that multiply to 1 times negative 9 is negative 9 and add to 0. The only way that two numbers can add to 0 is if they have the same magnitude and a different sign, right? So the numbers here that will work are 3 and negative 3. Does that make sense? Yeah, and then when you expand it out, you're going to get x squared and then plus 3x minus 3x. So that will always make 0x and then minus 9. Okay? But because it comes up a lot, we can just what you'll find is that you'll remember that, and then you'll notice the pattern and then just factor it directly. All right, so far so good? Okay, let's see what else I put in here. Oh. I see. Okay, this when it saved as a PDF went kind of funny. Okay, so here we have x plus 3 squared minus x minus 13 squared. Okay, and we want to factor this.
It's a difference of squares.
Yeah. So you could look at this and think, okay, well, I can expand and then factor that, right? And it would actually work if you did that. And you went like x plus 3 times x plus 3 minus x minus 13 times x minus 13. But if you look at the overall structure, if a equals x plus 3 and b equals x minus 13, what you actually have here is a squared minus b squared. Because you have the first binomial squared minus the second binomial squared. And this can be factored quite quickly using difference of squares, right? So what we can do with this is I would use some maybe bigger brackets because we're going to have brackets within brackets. But that's the overall structure. And then the first binomial in each bigger bracket is going to be the square root of x plus 3 squared. The square root of x plus 3 squared is just x plus 3. Okay? And then the second one is going to be x minus 13. Okay? So now we actually have some simplification to do, because within each of these sort of square brackets, we have some like terms. Okay, so when you're adding, the brackets aren't really that important because it's almost like you're distributing a positive 1 in there. It's not going to change anything. So this guy will become x plus x is 2x, and then 3 minus 13 is minus 10. Okay. For the second one, you may want to go a little more slowly because you're going to have x plus 3 minus x plus 13. Make sense? when you distribute the negative 1 in. So minus x is negative x, minus negative 13 is positive 13. Okay? And so this becomes 2x minus 10 times, well, the x's make 0, 16. Yes?
Do you then have like a common factor of 2?
Uh-huh, exactly. If you look at this first binomial, there's a GCF there of 2. So you can take out the 2 times x minus 5 times 16, and then you can just multiply the numbers together. So 2 times 16 is 32. So that is the fully factored polynomial. Okay. Now, I tend to use, I use square brackets throughout, and you don't actually have to do that. You can use curved ones for everything, but I would probably get rid of the square brackets, replace them with curved ones on this line, because I don't have brackets within brackets anymore. Okay, but it's up to you. Yes?
This might be a really silly question, but what's the point of factoring? Like, 'cause it's different than simplification, right?
Mm-hmm.
So what's the point?
That's a really good question. Okay, let's go on that tangent. Okay? So right now, there's no point in factoring. You're right, there's no point. Why factor? Okay. Well, remember I said that, I can't throw this pen or I'll get in big trouble. These pens are like $100. That quadratic function, which is something looks like y equals ax squared plus bx plus c, looks like that. It's a parabola. Okay? So let's say I have a function y equals negative x squared and then plus 5x. Okay, so you don't know what this looks like, but I can tell you that it makes that sort of arch shape. Okay? And let's say that y is the height of a ball. Okay, pretend you're kicking a soccer ball. Can you guys picture that? So you kick the soccer ball, and you can imagine, okay, so here's a person, and they kick a ball, and the ball goes woo, and then lands. Okay, so here's the ground, and we're going to say that y is the height of the ball at any given point. Okay, and x is time. Where is this ball? How high is this ball off the ground at any given time? Make sense so far? And the question is, when does the ball land on the ground? Okay, well, if the ball lands on the ground, what would the height be? 0. So what you can do is you can say 0 equals negative x squared plus 5x. Okay? Because y is height, so I'm replacing y with 0. Now, if I factor that, that's the factored version. Okay. We have to think about this. I'm multiplying two things together. The answer is 0. If you multiply two things together and the answer is 0, what does one of those two things have to be? 0. So either negative x equals 0. And if negative x equals 0, then x is 0. Or x minus 5 equals 0, which means x is 5. So what do those 2 points represent? X is 0 here. So ball is on the ground at the start. Okay? Height is also 0 here. So if we're measuring time in seconds, what we can say is it takes 5 seconds for the ball to land on the ground. Okay? So factoring can be a useful way, and this is just one example, for us to find out information about situation. Yes?
So it's like basically another way to just manipulate formulas to get your answer?
Yeah. So sometimes the question was, is it another way to manipulate some algebra to get an answer? Yes. Sometimes we don't want it factored. And sometimes we do. It just depends on the type of question that's being asked. Okay? And that's just one example of why it might be useful to factor. Tomorrow, or maybe today, but probably tomorrow, we're going to look at another one, which is essentially, it's called rational expressions, basically looking at algebraic fractions. Okay? And we'll see why it's important there as well. Okay? This is just probably this is, I would say, the most immediate reason that you guys will see, because you're going to look at this at the beginning of the next course in 20-1. And this is actually called a quadratic equation. Quadratic is anything that's degree 2. And so far, when we've been factoring, we've just been looking at expressions. There's never been an equal sign. Okay? But now we're putting an equal sign in there. And so we can actually solve that, and we can solve it by factoring, particularly when the one side is 0, because when one side is 0, you know that one of those factors has to be 0. It's the only way possible. If you take two non-zero numbers and multiply them together, your answer is not going to be 0. Okay? So that's one reason, and it's probably the one that you'll see the soonest. All right. Okay, you ready for this one? Okay, so I decided to put this question in. I haven't done it with the 10C class before, because I just did this with my Math 31 class. And when I did it with them, they were like, their mind was blown. And so I was like, you know what, let's just show it to you guys, and then maybe in a couple of years your minds won't be blown, and you'll be like, oh, yeah, I've seen that before.
Okay. Everyone
Okay.
else in the class freaking out, all of us just being like, yeah.
Okay. So, great way to sell it. Okay, so firstly, I'm going to do some stuff, and I wouldn't necessarily expect that you would think of this. Okay, but what I want to look at in this, it's not a polynomial, by the way. This is not a polynomial. Why not? Why is this not a polynomial?
Isn't it because they're all the same to the same degree? Well, not the same degree.
Has to do with the exponents.
Oh, it's because they're
Fractional exponents.
Yeah, fractional exponents are actually radicals. And this one's a fractional negative exponent. So now we have a radical in the denominator. That's not a polynomial expression. Okay? Yeah. So, okay, what I want to try and do is I want to see if I can make the last term a constant. Because if it's a constant and there's 3 terms, maybe what's left will be of the form ax squared plus bx plus c. Okay? If this is a constant, I have to take out an x to the negative 1/2. So I'm going to do that. I'm going to take out an x to the negative 1/2. Now, the last term should be plus 10. Let's just start with that.
Wait, sorry, I zoned out really badly. Can you do it really quickly again? I'm sorry.
Okay, so what I was talking about was I wouldn't necessarily I wouldn't at all expect you guys to come up with this,
Okay.
right? But what I want to try and do is make the last term a constant, just a number. Because if it's a number and I'm looking at something with 3 terms, it's possible that what's left is actually factorable. Yes?
So why? Oh, is that negative? Sorry.
Because if I take out the negative sign, like x to the negative 1/2 times 10 is 10x to the negative 1/2,
Yeah.
right? That's what I have to take out to make this a constant.
Oh, so you would be able to just take out x to the 1/2.
No, because x to the 1/2 times 10 is not 10x to the negative 1/2.
Yeah.
So I'm really focusing in on this. I say, okay, what would I have to divide by to make that just 10? The x to the negative 1/2, I'd have to take that out. Okay? Now, to figure out what's left here, you have to remember that when I take this, firstly, there's going to be a 3, right? Because I'm looking at the first term. And I need the exponent to be something where if I add negative 1/2 plus that exponent, I get 3/2. Because remember, if you think about this first term, right? It's going to be 3x to the something. Let's just put a question mark in there. Okay? Now let's go the other way. So x to the negative 1/2 times 3x to the something has to equal 3x to the 3/2. Okay? Now with our exponent laws, when you multiply two powers with the same base, you add their exponents. So you have to think, 1/2 plus what is 3.5? Or sorry, 3/2, 1.5. Yeah?
Do you have to do 4/2 because of a negative?
Yeah, so think about this. So even just think about this. Negative 1/2 plus something equals 3/2. Yeah?
Wouldn't it just be negative 3/1?
Well,
Oh, never mind, it's plus. Never mind.
maybe even convert these to decimals. Negative 0.5 plus something equals 1.5. Solve that. How would you isolate the question mark? The question mark's basically a variable, right? What do you have to do to just isolate that? Yeah?
You have to put 2.
Yes, or yeah? Think opposite operations. Yeah?
Personally, I reorder it so that it's something minus 1/2 is equal to 3/2, and that would be 4/2.
Yeah, you could reorder it as well. So some people will be able to do this in their head, right? And if you can, that's great. But you can also, if you want to isolate that, you just add 0.5. And then you have, okay, that has to be 2.
I actually got close to getting.
So this is 2. And it's more like if you think about going this way, 3x squared times x to the negative 1/2, if you add these together, you're going to get 1.5, which is 3/2. Okay? Then we're going to have minus 11x to the something else. I'm just going to put a blank in there because I don't like using the question mark thing, right? So when I expand these two together, I'm going to have this. X to the negative 1/2 times negative 11x to the something has to equal, oh, I'm running out of space here. Let me just do it. Even just think about this part. X to the negative 1/2 times x to the something has to equal x to the 1/2. Negative 1/2 plus what is 1/2? Negative 1/2 plus what? Yeah? Yeah, 1. Negative 1/2 plus 1 is 1/2, right? Or again, you could think of it this way. Just add 1/2 to both sides. And then that makes 0. 1/2 plus 1/2 is 1. Okay, so this is 1. Okay, so that's a 1. And if you think about going this way, right? X to the negative 1/2 times x to the 1, you have to add those together. 1 plus negative 1/2 is 1/2. Okay? Yes?
From S stuff, a squared,
Uh-huh.
squared, constant.
Yeah, so what's left, yes, is a trinomial of the form ax squared plus bx plus c. And so we have to see if that is factorable, okay? So here we're looking at a and c are 3 and 10. So we need two numbers that multiply to 30 and add to b, negative 11. Yeah? Negative 5 and negative 6. Okay, so I don't have a lot of space here. I'm going to go down below and continue this down below. And what I'm going to do is I'm just going to work on the trinomial part. I'm going to ignore the rest of it. Okay, so just let's look at the 3x squared minus 11x minus 10. And we know, I think what I'll do, because I already reviewed the box method. Uh-oh. Guys, sorry, I have to pause this. My kid's school is calling. Okay. So just to review decomposition, you can break this up. 3x squared minus 5x minus 6x minus 10. Factor this, you get x times 3x minus 5. And then here there's a GCF of 2, so minus 2 times 3x. Oh, this was a plus.
For the first thing, you take out 3x from that.
From this guy?
Yeah.
You might, okay, did you write these in the opposite order?
Yeah.
Okay, that's
Oh,
why.
wait, yeah, sorry, that's what.
Yeah, there we go. Okay, so it factors to 3x minus 5 times x minus 2. Okay, now if I put that back in here, okay, because this factors, what I'm going to get is x to the negative 1/2 times 3x minus 5 times x minus 2. Okay, and then actually, you could make this positive now. It would have to come down into the denominator, right? Right now, this is over 1. So if I bring that down, well, again, like I'm just showing this process to you guys so that you can see it. I'm not going to ask you anything like this, okay? If we bring it down, we're going to have, 3x minus 5 times x minus 2 over x to the 1/2. Now, as a radical, x to the 1/2 is the square root of x. Okay. Now, what I want to talk about is why this might be useful to do. A little bit, because otherwise we're just like running in circles, right? What's the point? Okay. So the point is this. This is in the form of sort of a fraction. Okay. So what are we not allowed to divide by? 0. Yeah. So if we want to think about what x values could we put in there, well, we certainly can't put 0 in. And then on top of that, you can't take the square root of a negative value. So the only x values that'll work for this expression, where this expression is actually defined, is when x is greater than 0. Okay? Now, it's hard to see in the original format. And so if I have it in this format, it's a little bit easier to see, okay, that can't be 0. Denominator can't be 0. The other thing that might be handy to see, and we just kind of talked about this when we talked about what's the point of factoring, is that we may actually want to know when the whole expression is equal to 0 as well. If the expression is equal to 0, think about a fraction. The numerator must be 0. 0 divided by any number is 0. So if we wanted to know when the expression was equal to 0, we could set this equal to 0, numerator, and then we could say, okay, well, either 3x minus 5 has to equal 0, or x minus 2 is equal to 0. And that may give us really valuable information about this expression. Okay? So this is one of the reasons why we do this manipulation. You are just learning how to factor. So I don't want to go too far into the rabbit hole of why it's important at this stage, except to maybe give you a little bit of foreshadowing as to why it might be important. I just want you to see the process. That's all. And if you can follow it, that's fine. Okay? All right, any questions? Okay, so I am going to stop there. And what I want you guys to work on is the next page. There are 10 factoring questions. And I want you guys to work on those ones for the rest of class.